I'm hoping after today, everything will make sense. That's the hope. I mean, as a teacher, I guess that's always your hope. But sometimes when I introduce a topic, it's a little, confusing at first. And then, anyway, okay. So when we're doing an FRQ, do you guys already have two that you know? You know a one sample Z interval for P, and you know a two sample Z interval for P1 minus P2. Those are the two things you learned in chapter 8 that you should know how to do. Okay, so now I'm giving you a third one, which is a one sample Z test for P. Test, this time's test, not an interval. Okay, and a test has hypotheses. So in the state, you're going to state the hypotheses. And we've been practicing writing those over the last 2 days. And define the parameter. So in the state, you're going to state the hypotheses and define the parameter. Okay, there's a lot of big words there. What I mean by that is exactly this. So this is from our notes from yesterday. Here's stating the hypotheses and defining the parameter. We've already been practicing that for 2 days. So we know most of that. Okay. Plan. Identify the correct inference method What is the correct inference method for something like this? It's already up on the screen. One sample Z-test for P, the title. Okay, and then, and check the conditions. Guess what? The conditions are exactly the same for chapter 9 as they are for chapter 8. You just have to keep on the lookout for experiment. Remember that? Random assignment. Okay. Okay, now this is the part that's new to you, the part that you don't know, how to calculate. Calculate the standardized test statistic. And that is Z. So Z score. And the p-value with normal CDF. So what you're telling me, Mrs. Sabat, is that we're just going to do a Z score calculation and normal CDF? Yeah. Yeah. Okay, now, formula sheet time. If you could please get out your formula sheets. We're going to write a couple things on them. And there's going to be something in here that you're going to find annoying. I highly suggest that you grab a highlighter, not for the formula sheet, but for your notes. There's a very important detail that you're going to be annoyed with. I'm just going to warn you ahead of time. Just be annoyed with the statistics, not the Mrs. Talbot. Okay. So you're in chapter 8 and you come down here and you say, okay, confidence interval is statistic, which for us was p hat or p hat 1 minus p hat 2 plus or minus z star times standard error. And our two standard errors, this was my one sample and this was my two sample. Does that make sense to you guys? Do you need me to go over that again? Is anyone in the crowd? You're good? Okay. Now, For a hypothesis test, you're right here. So this is chapter 8. This is chapter 9, standardized test statistic. And for ours, it's going to be Z. And the reason that it's Z is because we're doing a Z test. Okay. So the first thing we're going to do is write down the thing off of the formula sheet. So standardized test statistic equals. Now, you guys should hopefully have a tiny hazy recollection of the Z-score formula. Anyone have a tiny hazy recollection of the Z-score formula? No, not like in the calculator. I mean, okay, don't write this. Z equals, yeah, X minus the mean over standard deviation. This is what we did in chapter 1. It's back there. It's a ways back there, but I want to relate it to what is on your yellow sheet. So this says statistic minus parameter over standard error of statistic, except for this is kind of a lie. Okay. I'm going to explain to you about the lie. Since this is a one sample Z test, our standardized test statistic is going to be Z. Z equals. Okay. Our parameter is P. So P is going to be at the end of the subtraction because it's a one sample Z test for P. What is the statistic that goes with P? I heard it. Somebody said it. If this is the parameter, what's the statistic? I heard somebody say it. You're overthinking. It's just P hat. The sample statistic minus the population parameter. Yeah. Okay. Now, there's my statistic minus parameter. And you can think of sample minus population over a standard error of statistic. This is where you're going to get annoyed. Okay, you're going to go back here and you're going to see this. Okay, but this is not right. Look, why? Why is it not right, Mrs. Talbot? You want to use P in this instance. So what I'm going to do is give you a minute. You want to highlight. Okay. Let's talk about why we use P, and there's 2 reasons. There's gonna be some of you, no matter how many times I say it and how many times we highlight it, they're gonna put P hat in there. It's not really your fault. But let's try to talk about, at least getting your brain about why we would use P. So there's 2 things I want to say. First, we are making an assumption that we're innocent until proven guilty, which means that we're assuming the null hypothesis is true. What's the kind of thing that you write in a null hypothesis for P? Look back at yesterday's, the one I just showed you. It was like B, or was it A, state the hypothesis? It was P equals something, 0.63? Was it 0.63? Okay. since you're going through your whole test, making an assumption that the null hypothesis is true, then you want to use the stuff from the null hypothesis in your calculation. Okay, the second reason is we all know that P is more accurate than P hat. Let me just say that again. P, because it's the population, is more accurate than P hat, which is just from a sample. So you want to use P wherever you have it. This is the only time you're going to have it, so you need to use it because you have it. Okay, so here's the thing I just want you to remember. If you have P, use it. If you don't have it, estimate with P hat. So let me say that again. If you have P, use it. If you don't have it, estimate it with P hat. Okay. Hopefully, I'll bury in your brain here with that. Okay, and then our conclude is going to be reject or fail to reject based on alpha. We've already also been writing the conclusion sentence for the last 2 days. So we have been practicing everything in the FRQ except for the math. Okay, so let's do one. We're going to do Bernardo. You guys know who Bernardo is? He's the squishmallow, that's the burrito. With the little like foil around him. Please don't ask me how many Bernardos I have. I'm gonna seem crazy. I don't know, probably 4.
For Bernardo?
Mhm. Okay, but I have a really big Costco one.
I have a really big Costco one.
You do?
Well, actually, I'm scared of it because my cat peed on it and we can't
Yeah.
wash it.
And I have a Valentine's one where he's holding a heart. It's so
Oh,
cute.
so that's a completely different.
Yeah. And then I have a regular size one. Maybe I only have 3. Oh, look at me.
Now you need another.
I know. I have to go Bernardo shopping.
Actually, did I take it?
This is Bernardo, by the way. He's a burrito. Yeah. Oh, I have this clip too. There's no way I don't have the clip. So that's gotta be 4.
Jamie.
I think we have deduced that I have 4 Bernardo Squishmallows at home. I know, something wrong with me. I have the clip one. I have a Valentine's one that's holding a little heart. And I have the big Costco one and then I have a regular one. Uh-huh. They're all different. I mean, they're not all, anyway. Okay. Yes, honey. No, thank goodness, no. I do like them though. Every time we went in there, I was like, I don't need it. I don't need it. Okay, anyway. Okay. Example, Bernardo is bragging about his trash cabal talent. I would just like you to, for 1 second, imagine the little smiley burrito guy playing trash ball with his no arms. Okay. He claims to be an 80% shooter, but his team doubts his claim when he gets P hat equals 32 over 50, 64%. Ooh, might have just been a bad day. Does his sample proportion provide convincing evidence at the alpha equals 0.05 level that Bernardo is less than an 80% shooter? Okay, here we go. It's your first FRQ. Ho. Okay, a ho is always equals. And in this problem, we're working with proportions. So P equals 0.80. That is, nothing's happening. Nothing's weird's going on. We believe him. It's innocent. Okay. However, his team suspects that he's actually less than an 80% shooter. Okay. Now we need to define the parameter P equals the true proportion of shots made by Bernardo. Stop judging me. Just look at him. He's adorable. How can you say that? He's right there. Okay, anyway. See? He's doing it. uh, cleared that up. Okay, anyway. And then I'm going to just make sure that I restate the alpha value just for my end game here. Okay. Do you guys have any questions about the state? So the null hypothesis is always an equals statement, always equals. The alternative hypothesis is either greater than, less than, or not equal to. We have not done a not equal to yet. So hold on. The alpha came straight off of the problem. But if they don't give it to you, remember, you're going to go with alpha equals 0.05 as a middle of the road. And then defining the parameter, P equals the true proportion of shots made by Bernardo. Are you guys okay? Okay, now, plan. Next thing, one sample, Z test for P. Random, 10%. Large cats. Okay, so back when we played trash ball, we did some assumptions with our conditions. And if this is back when we played trash ball, it says assume 100 shots is a random sample of all shots forever. Okay, so we're going to take that concept here. We're going to say assume 50 shots you guys see where I got the 50 from? Okay, do you see it? You sure? Okay. N equals 50 is less than 10% of all shots. Definitely. Okay, large counts N times P. So N times P greater than or equal to 10. N times 1 minus P greater than or equal to 10. Oh, I think yeah, it's fine. It's or equal to. Check. Check. Okay, do. So we're going to find a z-score. Z equals, and I'm following this. So my standardized test statistic is Z. Z equals statistic minus parameter over standard error. Okay, the statistic is p hat, which is 0.64. So remember, statistic starts with S, sample starts with S, minus parameter. Parameter is P, that's right here. And then in my standard deviation, I need to have 0.80 because it's more accurate. Okay, grab your calculator. Oh my goodness, we're doing math? Weird. Negative 2.83 is what I'm gonna go with. Okay, do a gut check. How unusual is that sample? If it's negative 2.83 standard deviations low. It's pretty darn far out there, right? Almost into the tail. Okay. So you can kind of tell right here that you're probably going to reject the null hypothesis because this already is really small. But anyway, okay, so now p-value equals normal CDF. Okay. So this arrow is pointing less than, and this is super, super negative. I'm going to draw you guys a teeny tiny baby picture. Okay, so negative 2.83 is over here. So can you guys tell from my little baby picture that the low is negative infinity and the high is negative 2.83? And why am I using 0 and 1? Because I'm using a z-score. The z-score means that the center is at 0 and the standard deviations are 1. Okay, so now go normal CDF, do your thing. You got this. Go. Poor Bernardo. How unusual is this sample? There is a 0.2% chance of getting this sample just by chance. Yeah, that means that I love you, Bernardo, but you're probably lying about your trash kit ball percentages. Okay, since our p-value of 0.0023 is less than 0.05, we reject the hoe. We have convincing. Poor Bernardo, I feel like I'm betraying him somehow. Dang. Convicted. I want you to feel like a tiny rush of adrenaline when you reject a hoe. Yes, I discovered something. Haha. But except for the fact that it's about Bernardo and I think that. But still, maybe you have to choose some like an evil. Is there an evil squishmallow? I don't think so. What?
The clown is on face, which one?
Umberto is scary. I'm ready for Umberto to be gone from today.
Hmm.
Do you want to see Umberto?
I kinda got it now. Oh,
That's Umberto. He's just gonna go now. Does anyone want Umberto? No, you know you're gonna do something bad to it.
I don't want him, I said throw it away.
No, Jamie, what are you gonna do with it?
Only bit. Okay. No, I'll give it to you.
Okay. Do you guys have any questions about the FRQ? Does it make sense? Okay. Yes, honey. That's 5 times 8 is 40. Is that what you were? I'm sorry, I didn't mean to. Oh, that's for means. That's for means. Oh, hold that thought. Mhm. Did I get the answer right though? Yeah. Thank you. I did 0.2. I did like 1 minus 0.8 and got the answer and then wrote it.
Yeah.
Anyway. And then I was so freaked out that it was actually 10 that I must have screwed it up. Guys, did you find my mistake right here? This is supposed to be 1 minus. That I actually wrote the answer for 1 minus 0.8. Yeah, it's my fault. It's either 0.2 or 1 minus 0.8. It can't be both. Sorry about that. Okay, anything else though from the FRQ other than its adorableness? Okay. I mean, I don't like anything that's not breaded, really. That's probably not true. You could get a breaded and deep fried Oreo at the Santa Cruz Boardwalk. Uh-huh. Okay. Last bit. So I sort of spoiled this before. We need to talk about the difference between a one-sided test and a two-sided test. And then we're going to repeat what we did, but making it two-sided. We don't need to do the whole problem. We're just going to do the parts that would be different. Okay. How do you know you have a one-sided test? In your alternative hypothesis, you're going to have a less than or a greater than. And the problem is going to say something about less than or reduce or above or more than or something like that. So you're going to have a ha that's either this or this. Now, this is really important. Alpha equals 0.05 is your boundary level. So that means anything above this, you would fail to reject. Anything below this, you would reject. Does that make sense? For this particular problem. Okay. Alpha equals 5% on a one-sided test means that you have 5% here. And the resulting confidence level would be 90. Okay. Make sure you understand that before you move on with your brain. So a one-sided test is either going to be less than or greater than, meaning that the 5% alpha is located firmly in either tail. It's either in the bottom tail or the top tail, depending on if it's less than or greater than. And if there's 5% on this side, then there has to be 5% on this side. 5 plus 5 is 10, meaning there's 90 left in the middle. Are you with me? Okay, then that's what we've been doing all chapter basically so far. But sometimes the problem will say something like, not exactly like this one. It says wasn't exactly 80%, which means that your ha instead will have a not equal to in it. And you're going to have to get that from the wording. Okay, in that case, you take your 5% and you split it over both sides. So this would be 0.025 and this would be 0.025 because the problem doesn't say, is it less than or is it greater than? It's just saying, is it not equal? It could be either one, which means that instead that relates to 95% confidence. Where are you going to get this from? The wording of the problem. Okay, so we're going to do this problem again, but not really, because we don't need to do all of it. The only thing that changes, okay, so let's see. What if Bernardo's team doubted that his trash ball percentage of shots wasn't exactly 80? We already know it's probably not, but exactly. That's going to be your clue right there that you're not talking about a one-sided test, you're talking about a two-sided test. By the way, sometimes they're called one-tailed and two-tailed. One-tailed and two-tailed is the same thing as one-sided and two-sided. Okay, so what does that mean for us? That means that our ha would change to be p is not equal to 0.80. Okay, now looking back through the problem real quick, this wouldn't change. This would change. This wouldn't change. This wouldn't change. None of the conditions would change. The z-score would not change, but the p-value will change. Okay, so write it out. There was 2 zeros, huh? Okay. I wrote this exactly off of what we did earlier. This is the same z-score, same normal CDF calculation, same answer, except now I have 2 areas it might be. Could be low or it could be high. So literally the only thing you have to do is change this to not equal to and multiply your p-value by 2 because it could be on the low tail or it could be on the upper tail. Woo! That's it. Yeah. So if you have a situation with this with not equal to, change the ha, multiply the p-value by 2. And that's because there's 2 areas. That's all I have for you.